So now coming to Hive. Okay, again Apache Hive. This is, I've written there SQL on top of Hadoop. Okay, SQL on top of Hadoop. Okay, so this means that in Hadoop, whatever you are storing, till now you were able to do MapReduce programming, and you were able to get some results out of your data. Then we came to Pig. You were able to write some Pig scripts, and you were able to process the data. But now, if you have structured data load, okay, we have a lot of structured data as well in big data. Okay, so if you have structured data load, so instead of using MapReduce, instead of using Pig, okay, we can directly go for Hive. Why? Because your databases, okay, it becomes very hectic in your databases if you want to fetch data with a simple query as well, and your data size is extremely large. So it is very hectic to get the result in time. It may take half an hour or maybe 1 hour to give you the simple query result. And if you fire a query which is very heavy, then it might take 4 or 5 hours to give you the result. And if the result is not as per the expectation, you need to modify the query and then run it again. This actually happens. Okay, this actually happens. Okay, so sitting for like 4 hours waiting for the result, it's like very boring task basically. Okay, so if you want it to be quick, you can basically make use of Hive. Whatever data you have, you can migrate it into Hive, because Hive can create tables, okay, and Hive can run your same query on top of Hadoop, and your results will be faster. I explained in the first presentation that if you are using distributed computing, like if you have a framework where you have multiple nodes which are parallelly processing, your results will be exponentially decreasing the time, okay, at which we are getting the results. Okay, so that you can basically get with the help of Hive. Fine. So yes, Yahoo was basically working on Pig at the time when Hive was developed at which place? Facebook. Okay, so Facebook has got lot of structured data. Okay, Facebook has got a lot of structured, semi-structured, unstructured, like I think Facebook and your Google, these are biggest data gathering companies in the world. Okay, fine. So Yahoo worked on Pig to facilitate application deployment of Hadoop. Their need mainly was focused on unstructured data. That's why they were focusing on Pig. And here in Facebook, they started working on deploying warehouse solutions on top of Hadoop that resulted in Hive. Okay, because we had warehouses which was a traditional way. Okay, that was a traditional way of analyzing the data. So Facebook thought that why not to work with some warehousing solution on top of Hadoop itself. Okay, which can perform better than the existing traditional warehouses. So they came up with Hive that time. This is a first and simple architecture which was designed for Hive initially. Okay, so you can see the components available there. Okay, the components are you have that cloud type of picture, that is your Hadoop. So let us keep it separate. And on top of it, now you can see Hive. Hive has got a driver. Okay, so driver, we have compiler, optimizer, executor that actually interacts with your Hadoop system. Okay, on top of your driver, we have command line interfaces, web interfaces. So command line and web interfaces will allow you to query. Okay, and then you have your thrift server. On top of thrift server, you have JDBC and ODBC. Whenever you want to make connections with Hive, with Java or some database, for that your thrift server will allow you. We have installed Hive server, right? While installing, that is your thrift server. Okay, then you have a meta store. So I told you Hive requires a meta tables or system tables, so that is basically managed by meta store. Okay, so meta store we have configured in MySQL in our case, right? We have configured in MySQL. So meta store is that service which will interact with your MySQL and Hive, and will always make the meta information available to Hive. Because if your meta information is not there, you will not be able to fire any query, right? So this was the initial architecture which was proposed, and in detail, if you see, this is the architecture in detail. Okay, so you have a UI from where you actually write your query. Okay, once you write your query, that query is accepted by your driver. Driver manages your session. Okay, right? Session you understand, right? So once we start the shell, that is a session. Okay, whatever you write, so that is happening inside that session only. Okay, so driver manages that, and after that, that query is actually going to the compiler. Now compiler is translating that query or transforming that query into a DAG, directed acyclic graph, that because a query may be divided into 1, 2 or more number of sub queries, it may happen. Okay, so that is the work of compiler. After that, compiler does it with the help of metastore, because metadata is required. Okay, so it will take help of metadata. Okay, and after that is compiled, then basically that actually goes for execution engine. Okay, so execution engine, what does it do? It will interact with your Hadoop system. Execution engine will interact with your Hadoop system. So execution engine will interact with your job tracker. Okay, and your name node. For job tracker, why job tracker? Because job tracker will help out with the execution part. Name node will give the results. Okay, because result is a data stored in some data node that will be given by name node, that info. Okay, so your execution engine will interact with job tracker. Job tracker will get that particular operation performed, and after that name node will get those results, and those will be given to the execution engine. From here it will come to the driver. Driver will display it on the UI. Okay, so this is how internally the whole query gets executed. Okay, what happened? Okay, right? So your query comes to the driver. It is then compiled with the help of metastores, and then it goes to the execution engine. Execution engine interacts with job tracker. It is getting processed there, coming back to the execution engine, then driver, then UI. Right? Okay. The same thing has been explained here. Additionally, we have extensibility mechanism here as well. In Pig also we discussed that we have a mechanism of writing our own functions. Hive also gives us a facility to write user-defined functions. Okay, so that function is available in both. Okay, Hive and Pig. Right. Now, data model in Hive. Okay, in Pig we have understood we have atoms, we have tuples, we have bags. Right? In Pig. In Hive we have tables, we have rows, we have columns, we have partitions. Right? So it is more of a SQL kind of structure in Hive. So it is not very difficult to understand. It is easy in case of Hive. Yes. Then primitive types, integer, float, double, string, like Java and like SQL. Then yes, additionally we have associative arrays, we have lists, we have structures. So these are advanced data types in Hive. Okay, so there are certain advanced data types in Hive, and we have a format called as SERDs. Okay, so for example, data which is basically we are fetching it from web. Okay, so that is usually in the form of JSON format. So that kind of data is handled with the help of SERDs. Okay, so SERD, we will get different kind of SERD. For example, if we want to get Twitter data, so we will get a SERD for Twitter. If we are getting some Facebook data in Facebook in JSON format, we will have a SERD for it, because that it's not very much defined that how many columns are there, because JSON format is all key value pairs. So it is not what we can say fixed structure. There is a different structure for Facebook, there is a different structure for Twitter. Structure by structure, I don't mean that the way JSON format is organized, it is very same. Okay, but the number of columns, then JSON format itself may have sub columns. Okay, so there can be one key, and key can have value, and that value itself can be key value pair. Okay, so nesting can be there. So for handling all that, we have different SERDs which know that it is defined in the SERD that how that data is defined in Twitter, in Facebook. Okay, so different SERDs we can get. So these are advanced types supported in Hive. Okay, the query language, it is a subset of SQL. It like very much similar to MySQL. Metadata queries, limited equality and join predicates, no inserts on existing table can override an entire table. Okay, so this is about query language. So in Hive you can create your table, you can insert data. Okay, insert data means you can load a bunch of data. Okay, the whole data you can load at once. It doesn't support insert into table, then columns. Okay, doesn't work that way. You just load, you have data, you just load the whole data once. Okay, it is this way. And then if you want to update some columns, it doesn't allow that. Hive is not a database. Okay, it's not a many people call it as a database, but it's not a database. It's a data warehousing tool. It is used for OLAP. It is not used for OLTP. It's not used for OLTP. Okay, so therefore updates and changes in a row, it doesn't allow that. Okay, you can, as a bunch you can upload. Again, another bunch you can upload. So that will append to the data. Okay, but it will not update. Okay, so we have seen that SDFS does not allow us to modify the data. Similar way, Hive also does not meant for that. Hive is meant for analyzing your data. Okay, it's not for CRUD operations. Okay, and again, like, because it's a new tool, therefore join operations. Okay, we can perform joins. It is possible. Okay, but it's written there limited in the sense the way you can do it in MySQL, Oracle, SQL Server. Okay, the more richness you will find in the query there, here you will not find. Okay, the only reason is because it is newer, so updates are being always made. Okay, so still you will find in some new releases, some new updates are there. Okay, every time you will find some updates here. Okay, and yeah, last line I explained, it can append data, it cannot modify. Okay, you can again upload a bunch of data, so that those will be the new rows added. Okay, right? Fine. Data storage, as I told you, Hive uses SDFS as storage, right? Your SDFS is storage for Hive. When we installed Hive, we were able to see that there was a folder created for Hive /user/Hive. Okay, so Hive folder was created. So inside that there was a folder called as warehouse. Inside that we created a database. Okay, so Hive is by default using SDFS as a storage, and whatever tables you are forming, whatever data you are storing, so there is a some kind of reflection in SDFS for that. For example, if I created a database in Hive shell, what happened in SDFS? In SDFS, one directory, a folder was created. Okay, if I create a table in Hive, what will happen? In SDFS, again a directory will be created. Okay, if I insert something, what will be happening? No, if I am inserting some data, there will be a file created. Data is stored in a file. Okay, so if you create a table in SDFS, there will be a folder. If you insert some data inside that folder, that data will be loaded. So if you will go in the SDFS browser, you will be able to click and browse. You will be able to see that particular folder. You will click on tables folder, you will be able to see that file. You will click on file, it will display the data. But on Hive, if you will do, you will have to do show tables, select star from table name. Okay, you will be getting into the table format. Okay, so but internally how that is being stored, I am telling you, right? It is stored in the form of folders and files. Are you getting, right? So database is a folder in SDFS, table is a directory in SDFS, and your data is a file. Okay, then if you want, you can basically organize your tables into partition. Let's say we have a team from different cities, and we have a frequent query of calling the names of cities from different cities. So every time in the query we need to put city. So instead of basically writing the running the query again and again on cities, okay, what I can do internally, I can partition the data on the basis of city itself. Because if I will partition, then the query will have to do nothing. It will just fetch that partition and display. Otherwise, it will read the whole data. Let's say there are 1 lakh records. It will read the 1 lakh records, and out of them, it will fetch all those records which belong to that city. But if I will create partition, it will just look for that partition and fetch all the data and display. Are you getting? Right? So partition is something like this is Nasik, this is Pune, this is Mumbai. Okay. So Nasik people are sitting here, Pune people are sitting here, Mumbai people are sitting there. Okay. So I'll just query. Okay, people where city is equal to Pune. So city is equal to Pune. Okay, this is Pune. All the people will get reflected. But otherwise, what it was doing, It was reading this, it was parsing this, it was parsing that also. Complete data it was parsing. So if you want to create a partition, then partition will be created inside a table, and that will be a file or folder. Directory, obviously directory, because inside that directory your data will be present, right? So this is how data is stored in SDFS. But for Hive, you have databases, you have tables, you have partitions, and you have your data as rows and columns, right? Are you getting it? Okay. Pros and cons: it's easy way to process large scale data, supports SQL based queries, provide more user defined interfaces to extend. Programmability is possible, efficient execution plans for performance, interoperability with other database tools. These are pros, advantages of Hive. Cons: no easy way to append data, as I told you that you can, whole file you can upload, again whole file you can upload, but it's not like you can just upload few records by insert command. There's no mechanism for that. Files in SDFS are immutable. That's another challenge, because the files are immutable, therefore we are not able to do this. You're getting, because files are immutable in SDFS. Future work, so work is still being done. Views and variables, more operators, this is all comes under future work. Like views, there is a facility of views to be created. Okay, there is no kind of programming in case of Hive. Programming in the sense, if you want to program, you have to use Java, as I told you, for user defined functions. Okay, but in case of like SQL, we have a PL SQL branch as well, so there is no as such branch in case of Hive. Okay, so so it says that still lot more work needs to be done on Hive, and we need to remember that it is used for OLAP, not for OLTP. So that is something we should always consider. Fine. Applications you were asking. So Hive, Pig, MapReduce, we can have these. Wherever you see, I see applications. Okay. Wherever whichever field of business I see, these tools are used. Okay. You can name any. Everywhere these are being used. Okay. But just to list out, there's a lot of log data for log processing. These tools are being used. Daily reporting we can use. User activity management, data and text mining, machine learning, business intelligence, advertising, spam detection. So these are certain areas where your Hive can be used, your Pig can be used, and obviously MapReduce can be used.